Hey, I'm going to do something a little different in this video than all the other videos I've made to date because I'm a structural engineer. Hi, Paul Kassabian. Good to meet you. And every one of my videos, whether you've noticed it or not, has actually been about something that is essentially eternal, we'll say, right? Physics. It's physics-based structural aspects of design and behavior of structures, right? So whatever video I've made about, let's say, a truss or a dome or a bicycle wheel, that has always been the case of how it's worked and will hopefully, because I don't see any reason why it wouldn't, continue to be the same. So if you watch those videos in a few years from now, they would still be just as relevant. And so therefore, I've been holding back doing a video about the current rapid rate of change, because it's changing faster than ever, it feels, in technology and how that affects what we do as structural engineers. And so, but it felt that having actually done a few sort of online webinars and different presentations on this topic for a number of years, just within the company I work at, SGH, and to other clients and just online, I felt I should really do something about that here on my YouTube channel. It aligns with something that I care deeply about, and that is something that is a phrase I've used repeatedly, but is something that is more meaningful now than ever before, where I've said repeatedly, we do not need more engineers. We need better engineers. And I've said this for years and years and years, and it's mainly been related to things to do with structural design, structural conceptual thinking. But now what I really want to add and bring into this is the aspect of where are we going with technology? What does it mean to be human? What does it mean to remain in a profession going forward if there's such a value to such a thing? Okay, so we're not necessarily going to deal with absolutely every single one of those in greatest detail today, but I have been giving it a lot of thought and I wanted to share those thoughts with you. So a really quick background on me, just to set the scene for why I've been giving this a lot of thought, right? I've had a really excellent education. I went to Westminster School in London. I then went to Cambridge University. I worked on some really great pedestrian bridge designs. I came out to Boston, Cambridge, Massachusetts to go to MIT. I then taught at MIT for many years and Harvard while working here as a structural engineer full-time at this firm SGH, and I'm now a principal here. And it's been a great ride of projects and experiences and relationships with clients. I've done projects ranging from sculptures to houses to ancient structures, ancient for America, over 100 years, but really great sort of historical structural upgrades, adaptive reuse, materials ranging from, 3D printed glass, 3D printed metal, 3D printed concrete, bamboo, corian, doing a whole bunch of work with modular structures, and just all levels of scale on structural projects. And all of that has been super, super fascinating. But I think we're entering a stage of rethinking what we're doing as structural engineers and how we're going to use technology. We are in what has historically been one of the slowest moving industries, the construction industry. It's generally risk averse, and for good reason. It deals with human life safety, right? So you wouldn't want people to be winging it. You wouldn't want people to move fast and break things fast when it relates to structures that we live, work, and play in, right? Like this is essentially a responsibility for society. However, technology is moving at a rapid pace and is making us rethink how we provide our services. Take a look at this list of all the current technologies that are impacting and growing within the construction industry or the design and construction industry. There are tons of them. You can read multiple articles on any single one of these, and they are all happening at the same time. I also find it fascinating that we could have, and I'll just take as a really quick example for how we should be thinking clearly. You can have arguments for how 3D printing is the future of construction and arguments for how modular is the future of construction. And in many ways, those two things are opposites, right? 3D printing is fundamentally based on customization. Modular is normally based on standardization. 3D printing is often done out in a field. Modular construction is normally done in a factory in general. Right? And the 3D printing might be for unique, customizable situations, whereas modular would be more about how much repetition can you get. So This is not me picking sides. There aren't even sides to pick from. The mistake is where people say something like the future of construction is 3D printing or will be 3D printing. And I think the right way to think about this is that the future of construction will contain 3D printing, will involve 3D printing, will involve modular, will involve all those other technologies that we just went through on the list. That is generally how technology works. For example, when you want to cook things, you have a range of options. You can grill something, fry it, bake it. And then when microwaves came along, which could heat food quickly, microwaves didn't replace all those other ways of cooking. You can just now also choose to microwave your food, right? Like, we're essentially layering options here. And that's something that's important to think about related to the construction industry that's had such a long history. We are working not from a blank slate. We are working from a setup, an existing setup that will not go away, but we are working from that multiple layers of history and pattern and comfort level and supply chain and industry norms, and we are building new layers on that. So will there be progress? Yes, but it isn't progress in a vacuum. Let's look back really quickly at a set of other jobs/professions that were important in the past and then changed. So for example, scribes. If you were a scribe, well, your mother would tell all her friends about you and would be very, very proud. There you were as a scribe. You were writing often the word of God, or you were putting these books together in fancy ways, and there was knowledge in these books. And you got to, I don't know, one book every few months, or I don't know. I honestly don't know, but you didn't do it that quickly. And so you can be a scribe and you were valued for many, many years, centuries. But then Gutenberg, thank you Gutenberg, printing press comes along, and we have the mass outreach of information, something that hasn't been beaten since the internet sort of came around. So it wasn't just that you could produce books quicker and cheaper. It was more the benefit that information spread around quickly and was more democratized. So scribes were no longer needed, but books were still written. Scribes who wrote books out of a job, authors of books still have a job, right? Another one would be, let's look at the Industrial Revolution, weaving the supposed character Ned Ludd, if he ever existed, and the Luddites, and the oversimplified story, putting aside labor unions and the understanding of all of the issues that were actually going on. The general story told that helps us here is that in terms of how the weavers were smashing the new machines that would do the job instead of them, right? It's a wild simplification of what actually happened, but it is representative of what we often see, that when you have a job and something can do that job or some of that job, people generally push back. They don't want that because they define their value as the job they are doing. And they can confuse those two things, right? And in general, society progresses on, and we're all wearing clothes that are not, for the most part, certainly not me, hand woven, right? So things like scribes and weavers and farmers and horses, as those other examples, they don't go out of a job because they failed to do their job. They just became essentially economically obsolete. Right? We still have horses around, but they don't do all the jobs that horses used to do with sort of transport and going to war and all those sorts of things, right? So the key part, as there is technological transition, is to understand what your value is. Now, as computational approaches have increased over time, generally from a structural design background, we saw it a lot from the 90s with parametric architectural design and geometry changes, and that sort of produced immense power in computational abilities that have then led to the more recent discussions and progress in machine learning and AI in general. Machine learning's been around for a while, but really in terms of its applicability and access by all. And I wanted to share a few examples here of some of the work we've been doing in the past on computational approaches related to our work. This is not supposed to blow your mind, but what we were doing on actual projects was thinking about other ways of doing our work, right? We're still structural engineers. We have to be responsible for the structural design, but the process of that, the process is something that can change. I've often said in many ways that structural design is not sizing a beam. right? It's deciding to have a beam in the first place, right? So you can do analysis, which is sizing a beam, which has been automated by computer software for many, many years now. But the actual concept of how do you think up a structural design, how do you interact with others? So a little animation that's playing right now is to show you, well, can we show what happens as heavy weights move across a certain structural load? This could be, for example, in a museum where there's going to be a very heavy sculpture placed in a position where you have to get that heavy sculpture there, right? And so in this case, rather than saying or answering the question, is it okay? We're both getting more involved in the actual physical realistic process and making this a sort of live interaction, fully understandable thing that people can decide whether they want to change aspects, and people can understand what's actually going on from a more visual perspective, right? So this was just on a specific project, but we were looking at ways to show computational and technological approaches. Here's another example. This is actually a tool we developed that we shared back with the architect, actually a landscape architect, designing a project related to some tensile canopy where there was an interaction between the geometry of what you would see, the hung cables between the different columns, but then also what the foundations of those columns would be. If you can see they're changing shape as we change the geometry of the cables, more saggy cables, less force, smaller foundations, because that was interacting with some existing buried infrastructure. So there's a lot of moving parts. How can we, in terms of not necessarily trying to solve for one solution, is it okay, but more along the lines of developing a design process with the architect on this project. So we developed the tool, we shared it with them so that they could use it as they were doing their design work, right? So essentially our value wasn't waiting for being asked questions, it was providing the valuable process part. I was also the structure engineer for the new carbon fiber and glass fiber canopy at the sort of entrance to MIT. This was made by boat builders, and we used machine learning to optimize for the placement of the columns. I cover this in more detail in a separate video, and we have a technical paper on it. But this is more about the idea of thinking, hey, are there ways of thinking through complicated problems such that we can provide a range of better solutions? So we actually applied exactly the same technological thinking to how to place optimally piles, which are essentially think of them as columns in the ground, piles under pile caps, sort of a top, when the pile caps are loaded in a non-symmetric manner. So it's actually quite a hard problem to solve, right? You have a simple symmetric load, you can just symmetrically place the piles underneath. So when you have something that's not standard, what we call an eccentric load that's bending everything around, then to find the optimal layout is not so obvious and usually can be trial and error. So we actually put together a machine learning aspect that could look through a range of options and determine which could be the minimal one in a very difficult, complicated sort of solution space. Now, that is interesting and excellent in that it has a practical application, but it doesn't necessarily scale to the wider role, right? We went one step further in terms of sharing a process. It occurred to us that, again, under that heading of architects or designers ask an engineer a question, and then when you get round to doing work, you answer them back. Can we just provide continuous access to a tool online? So for a project here, which was about a range of different loads that might go onto, it was an existing concrete waffle slab with really bizarre reinforcement. So again, no obvious solutions, but to give them immediate feedback. So if they were working on this at 11 p.m. or midnight and we're not around, or during the day, but we're in a meeting, they could just go online, access an interface, do something that was very obvious visually to them, that would call our servers, have the structural model loaded in the way it needed to be, get the results, and then provide them back in a sort of visually understandable manner, like you're seeing here with the sort of red zones. When we first shared this with the architect, they were blown away. They were really thinking, this is amazing. The project architect was just going, the next morning said, I just kept playing with this. It was fantastic. Thank you so much. What was interesting though, because we thought we'd really nailed this, is it didn't really finish off the process. There's still that lack of connection with us. They still said, okay, I did this, but I had other questions and I would have liked to have asked you them at the same time. So it got us thinking a lot about the difference between technology, or thinking you have a technological solution to something, and the sort of human process involvement and explanation. In fact, this project, more than any, was one that just kept reminding us, as engineers, don't always think that the problem is an engineering or technical or technological problem to solve. It might be phrased that way, it might be asked of you that way, but behind it, there's more likely a more involved problem, and it is a harder thing to try and figure that out. So this is an interesting stage we're in right now, right? Like, it's easy to look into the past and see the examples of people getting concerned about physical automation when the machines started to take over an industry. There was also when calculators appeared at schools, people thought that was going to ruin how people learnt maths, depending where you are. And then with the recent surgence of large language models, the current timing of this video, it's ChatGPT is the one that a lot of people are talking about, that there's been a lot of pushback related to the use of that and what it means. But really, if you think about it, we've moved from physical automation to computational automation, which we are comfortable with. We use Excel spreadsheets and calculators. And now we're really entering the land of thought automation, right? It's not something we've talked about a lot, but I think part of sometimes the discomfort or the joy, which depends on how you are reacting to the new technologies that are being developed, that this is something that, because it's in language or increasingly also in image and video, it is becoming the same way that we think. Like, in our minds, we think in language and potentially sort of images and video, and in our dreams, right? Like, how we conceptualize things all relates in the same form as we are seeing coming from these new technologies being developed. I think that's the intersection that is super, super interesting right now. And it is now on us, as all of this is changing, to think more, how should we be behaving with this technology, right? Quick pro tip. When anyone starts to say immediately, well, I've been using one of these new technologies, GPT, let's say, and I tested it and it got something wrong. Okay, right there, that is the human that you're talking to. That's their problem. That's their arrogance, and that's their ego, and that's their self-defense coming up. Embrace the fact that these technologies are here. Recognize the fact that these technologies today are the worst they're ever going to be. They're only going to get better. And also recognize the fact that we are all beneficiaries of all previous technologies up until today that we have got perfectly used to dealing with. So anyone who is pushing back against whether it's them versus the technology or what is it not good at, you're simply delaying your own personal evolution in terms of getting used to the technology. And I'm not saying I've totally figured this out for myself. I do know it is going to be a little bit of a kind of uncomfortable teenage period, right? Where we're sort of growing into what might be a better situation for us all in terms of where we're working and thinking, right? What I've been trying to do as much as possible, and I think all of us, especially those who are watching who are professional structural engineers, because we're generally trained in a more analytical approach, is to spend extra time empathizing with your clients, trying to put yourself in their shoes, asking why, what is going on, what do they care about? Because as human beings, we are a mix of emotions and logic, and yet for some reason we judge each other as if I'm thinking logically and you're not, right? Which is just bizarre in terms of you cannot be right all the time. That is clearly not. I mean, obviously, but just think about how can you empathize with your client, which is just, I mean, boy, can it be tough, right? If you ever try it with someone else and you sort of say, oh, well, what's bothering you about this, or what's going on, and they're giving you answers that maybe aren't very helpful. And you have to keep digging. And then when you're done, you sort of think, am I done yet? Can I just go and do my work in peace and quiet? Right? Then at that point, that's when you probably have to empathize some more. And you know what? they're probably not going to empathize with you, because that's just how we all feel all the time, right? So the more we can be doing and empathizing with our clients, the better we're going to understand the problem. A well-defined problem means you're closer to the solution. A badly defined problem means you're just going to be solving not the right problem and wasting your and everyone else's time. Something else I've been thinking about, which is something we've been hearing a lot right now, which is, it isn't going to be the technology that beats you. It's going to be the other person using technology that will beat you if you're not using the technology, right? So it's a little bit like that classic story, two friends in the woods, there's a big bear, comes up, and one friend ties up their sneakers, their trainers a bit better. The friend says, you can't outrun the bear. And he goes, I'm not trying to outrun the bear, I'm trying to outrun you, right? So great friend. But there's that whole aspect of you don't have to be the fastest or the best. You just have to be relatively better. Okay, that's been talked about quite a bit by lots of different people. I think an interesting thing that is going to happen sooner rather than later is it's not so much you versus someone else using technology, or let's say you as a structural engineer and another structural engineer using technology. It's more because this technology is so accessible, when our clients are going to be using the technology first. And by that, I mean there is nothing stopping right now any client going to GPT in its current state and asking it a set of questions instead of asking you. And GPT, it doesn't matter whether it's perfectly right or not, but pretty quickly, it's going to give that client 80-90% of the way there. From the client's perspective, they may be getting everything they need. And you know what, if you've ever paid attention in the current state of large language models, they respond in a very positive and kind manner, right? At no point do they ever eye roll. In terms of not thinking about yourself and your risk and your responsibility, think about what the value is you're providing. If our clients can access technologies easily that are communicative with them, and they can get a lot of the value they need, that's why we need to be thinking about the value we're providing. It's sort of making sure we're upping our game. So let me give you a quick example of something outside of my field of structural engineering, but very relevant in our lives and directly related to my closest friend, Daniel Hahn. Daniel Hahn, OBE. So look him up on Wikipedia. He is a translator, writer. He translates from many languages, typically into English. And you might think, if you are not a translator, you might think that he should be out of a job. After all, you can go to Google Translate and put in text in any language and have it translated to any other language. And currently there are even a whole set of new technologies that are doing like the Babel fish that was in Hitchhiker's Guide to the Galaxy, right? Like simultaneous translation between languages, which is astounding, right? And that's where we are now. So if you're watching this video in the future, it'd be fascinating to know where we are then, where you are now. Where are you going to be? You're going to be there soon. Okay. The part I want to talk about Dan is that he has a really interesting phrase. He says, or the way he explains his work, he says, when I translate a book, I don't change anything about it except every word. Which I think is just beautiful, right? It's essentially reminding us what the point is of what he's doing. It isn't a word-for-word translation or mixed over. It's the fact that if he's reading the original, again, this is his example, if he's reading the original and there's something in the original that is funny and it makes him laugh, then his job is to make the reader of his translation also laugh. You can't translate the joke word for word and then in the footnotes explain, okay, here's why this is amusing and you would laugh at this particular point, right? That takes people out of it. It ruins everything he's trying to do. And by the way, and this is, I got to plug, he's my closest friend. He's done this excellent book called Catching Fire, a Translation Diary. And you might not be into translation or care about translation, but you know what this is? Little chapters where he's dealing with problems about translation, but really it's just about what is it to think? What is it to do your work as a person as you're thinking through the parts that you can be valuable at? Yeah, I just ended a sentence with a preposition. That's why I'm a structural engineer. So where are we going after this? So just think about a few other aspects, and I just wanted to share some thoughts. The end of this ending part of the video, I don't have a clean ending because no way can I have a clean ending. If I did, then it would just be to make things easy. And this is very much a continuous process. But a few thoughts I wanted to share, just to round this up. We have got a situation where I think not only is technology moving so fast that we're going to be thinking about the ethical implications today, meaning when should we or shouldn't we be using AI in our structural engineering or in our profession, right? So a good example would be, well, who's responsible for it? Fine. And who might have better experience? Fine. But think about the fact that as AI develops, and comes up with the trolley problem with self-driving cars, what does it mean when a technology that can maybe look back at a whole set of data on how other projects are done or have been done and have been successful? What if a technology is developed that can show it can do better than an equivalent human being? At that point, ethically, if we're talking about the design of structures, shouldn't we be required to use that technology? Before we get to solving the ethical part of when should you or must you use technology, I think before then, we're going to get clients insisting that we use the technology. In other words, I am client. I am aware that there are technologies out there where you can do this work faster or more accurately. I expect you will use them. And so in this developing role of standard of care, which is its own topic, but it's related to how we judge the quality of professionals, right? And you judge it as the standard of care is whether similar professionals doing a similar job in a similar location at a similar time, how would they have done it, right? And so if in a position where I am in, I live here in Boston, Massachusetts, developed society, access to a fast internet and all the tools I could hope for, to what extent is it now typical that we should, I don't know if typical is the word, be using these technologies? They're certainly accessible and there's nothing stopping us. I don't think right now all the professionals are, but I think clients could start asking us and will be asking us or expecting us to do so. So it's up to us to get ahead of this or at least keep up. And I want to finish off with something that's obviously very near and dear to my heart. It's why I started this YouTube channel to begin with. It was in the fall of 2020. It was weird with people doing remote learning, and I wanted to share a way and contribute to education in general, right? And my biggest concern related to how we are teaching engineers right now is in the sort of methodical, analytical approach, which, again, you can consider that fundamentals, but I think we are missing the opportunity to teach engineers for what they are needed to do today, not just what they're going to need to do tomorrow, right? I have personally an immense concern with any approach to teaching where then there is a multiple choice test as a result or a way of judging it. Multiple choice tests, really. I've done teaching for 15, 16 years. The first year I taught, because I was scrambling to fill exam questions, I asked a few multiple choice tests and I saw how people were answering them. And I fell into those traps where, one or two of the answers are obviously wrong. One of them's got a trick in them that you're hoping that they'll slip up. And then between two of them, it's if they got their units correct. Did they go from feet to inches, or meters to centimeters? So, right. So did we do that? And that's not testing intelligence. You're just trying to, it's such a weird way of doing this. I think fundamentally, and it's a true belief of mine, that multiple choice tests are only good at testing if you're good at multiple choice tests. That's it. They're very circular. I just think we need to be teaching better understanding and better thinking. And that's not easy, but it's where it starts, and it starts today. Education is fundamental because you're not just teaching the classic, facts. And as people say, oh, I'm teaching the kids how to think. The thing is, you hear that everywhere. Every grade school, high school, and college will tell you they're teaching their students how to think. Are we? Are we though? Because I haven't seen the syllabi changing extensively across different disciplines and courses. It tends to just be some of the same stuff, with obviously some excellent work. But across the board, we could be teaching a better way of thinking. It is far more nebulous. It is far less prescriptive in its manner, but it is the very necessary way that we will be valuable and grow as structural engineers in our help for society in general going forward. I think it's going to be exciting. I'm looking forward to the ride. I hope you are too. Thanks. If you like this video or any of the videos that I've been doing recently about structures and material and form and design thinking, like and subscribe. See ya.